Assalamualaikum and good day to everybody. I'm here again with you. My name is Siti Fatimah binti Haji Ahmad Zabidi. I'm from Faculty of Industrial Sciences and Technology from University Malaysia Pahang. So here again we are going to learn how to find the volume of revolution for a solid which is having a hole. Last time we used this method. This method is for volume of revolution where there is no hole. Okay, so start with this one, volume using washer method. Okay, so what is a washer? The washer is a thin plate with a hole, and the cross section of a washer is a ring, and it's called annulus. Okay, this is washer. You have the washer here, and you have the annulus here. Notice that for washer we have a hole here. Okay, the cross section is annulus here. So for annulus here, we have the inner radius and we have the outer radius. So the inner radius is the radius of the hole. Okay. So area of annulus is area of the outer circle. So we have the outer circle here. And then we minus the area of the inner circle, which is the hole here. So the area of the outer circle is pi r squared, because the outer r is the bigger r here, and minus the area of the inner circle, which is actually the hole here. So minus pi r squared. So when we factor out the pi here, we will get A equivalent to pi r squared minus r, the big R squared minus the small r squared. So now the volume of a washer, let's say this is a washer here. We have washer here, then this is the hole here. So a volume of washer, let me put delta here. Delta V is equivalent to pi r squared, the outer radius minus the inner radius, and we will multiply that by the thickness. Okay. Now let's look at a region. Look at this region here, the yellow region. Say the yellow region is revolve about this x-axis. So when we revolve about this x-axis, we will get a solid where there is a hole here. So the volume of that solid will be from, we integrate from A to B, then pi r is the bigger outer radius, which is the outer radius here, the bigger r here, minus the inner radius, which is the radius of the hole from here to here. Notice that the radius, the outer radius is from this x-axis to the curve here, which is y equivalent to fx. So the outer radius will be the fx squared. Okay. And the inner radius, notice that the inner radius is from the x-axis to the curve here, and this curve is y equivalent to gx. So gx is the small r. So when we square it, we will get gx squared. Okay, we use this formula to find the volume of revolution of a solid bounded by the curve here, y and y equivalent to fx, and also y equivalent to gx from A to B about this x-axis. Okay, let's look at this example. Example number 1, we have the region bounded by the graphs y equivalent to x over 2 plus 1, which is actually a straight line, and then we have y equivalent to x squared plus 2, which is the parabola here, and then x equivalent to 1 and the y-axis, and we revolve it about this x-axis. So we want to find the volume of the resulting solid. So notice here that we have this typical triangle which is perpendicular to the axis of rotation, and then we will have this small r. Okay, from r is from this x-axis to this line. So this is the radius of the hole, and then we have the length from this x-axis to the parabola, which is the radius of this washer. So the big R is x squared equal plus 2, and the small radius, inner radius, is x over 2 plus 1. Okay, this is the small radius, and this is the radius of the washer. Okay. Okay, we have just now the region bounded by y equivalent to x over 2, and then we have the parabola y equivalent to x squared plus 2, and then we have another line x equivalent to 1. Do we have the y-axis which is x equivalent to 0, and we revolve the region about the x-axis. Okay, so we have the radius, the outer radius, we call it big R, capital R, and then this is equivalent to the parabola x squared plus 2, and when you have inner radius, which is the radius of the hole, which is x over 2 plus 1. So we have the volume, which is integration from 0 to 1 x pi. We have the outer radius, we square it, and then the inner radius, we square it. Okay, then we integrate it with respect to x. Okay, in this example, we have V, volume of the solid of revolution, from 0 until 1, we have pi, and then we integrate this x squared plus 2 squared, which is for the big R, outer radius, minus the inner radius, x over 2 plus 1 squared. We integrate it with respect to dx. Okay, so then we will have equivalent to, we can factor out the pi, put it outside the integration because pi is just a constant, and then we expand this, we get x to the power of 4 plus 4 x squared plus 4, and we minus, we expand this one also here, we have x squared divided by 4 minus x minus 1 dx. So we expand this, we get this minus x squared over 4 plus minus x minus 1. Okay, so then we will integrate, we get pi from 0 to 1, integrate this x to the power of 4, then we add this 4x squared and minus x squared divided by 4, we will get a 15 over 4 x squared, and then we have minus x here, So we put minus x, and then we add 3. So 4 minus 1 will give you 3. Okay? So we will then integrate that result. Okay? Just now we have just repeat the one that we have got just now. We have, let's say, we have v equivalent to pi from integrate from 0 until 1. We have x to the power 4 just now plus 15 over 4 x squared, okay, minus x plus 3. We integrate that with respect to x. So we will get pi, this one, integrate that x power 4, we get x power 5, divide it by 5, the new power, plus, we have 15 here, divide by 4, so x squared, we integrate x squared, we get x to the power 3 divided by 3, and we minus, integrate x, we get x squared divided by 2, integrate 3, we get 3x. So we will substitute 0 and 1 in. So we will get, here we will get pi, and then substitute 1 in, we get 1 over 5 plus 5 over 4. And we will minus 1 over 2 plus 3. Okay, substitute 1 in. We substitute 0 in, we'll get 0. So we will calculate it, and we will get 79 over 20 pi. Okay, so that's the first example. Now let's look at another region, tau region, but now this region is revolve about this y-axis. Okay, so if we, let's look at the green region here. If we revolve it about this x-axis, the y-axis here, we will still get this here, and then we will find the inner radius and also the outer radius. We measure it from the y-axis. So the volume of revolution will be from C to D. So C to D here. We use the same formula. Pi, outer radius is square it, and then inner radius we will square it, and then we will integrate from C to D, pi, okay, function in terms of y here, we square it, minus gy, we square it, okay. In this example, we have the region bounded by the graphs y equivalent to x squared plus 1, which is the parabola, okay. And then we have y equivalent to 1, which is the straight line here, and then we have x equivalent to 1, which is also the straight line here. So this is the region, and then we want to revolve it about the y-axis. Okay, we revolve it about the y-axis. Notice that the inner radius is that length, okay, and the outer radius is the length from here to this line. See, the outer radius is just 1. Okay, from here to here, this is just 1. So the outer radius, capital R here, is equivalent to 1, the outer radius, and the inner radius is Ry equivalent to square root of y minus 1. Okay, how do we get this? I will let you know after this. Okay, so let's look at that region. We have just now the region y equivalent to x squared plus 1, which is the parabola. And then we have the line y equivalent to 1. And we have another line which is x equivalent to 1. We want to revolve it about this y-axis, about the y-axis. Okay. So we know that the outer radius, we call it capital R, everything will be in terms of y, but now we have 1 here. And then the inner radius, just now we have this inner radius from the y-axis to this parabola. Okay, so we know that parabola y equivalent to x squared plus 1. So we will get x squared is equivalent to y minus 1. So the x value is actually equivalent to square root of y minus 1. So that's why our inner radius will be, in terms of y, will be square root of y minus 1. Okay? So again, the volume of the solid, we revolve it from 1 to 2. So pi. So the outer radius will be in terms of y. So the outer radius, we square it minus the inner radius, ry, we square it, and we will integrate it with respect to y. Okay? We have volume equivalent to, we need to integrate from 1 to 2. We have pi just now. The outer radius, we know this is equivalent to 1. We square it minus the inner radius, which is square root of y minus 1. We square it. We integrate it with respect to y. So we will get pi. Okay, we put the pi outside the integration because this is just a constant. Integrate from 1 to 2. So 1 squared give us 1. We square this, we get y minus 1. We integrate it with respect to y. So we will get pi from from 1 to 2. So 1 minus 1 will give us 2 minus y, and then we integrate it with respect to y. Okay? So we will get volume equivalent to pi. We calculate this. Just now we have 2. So integrate that 2, we get 2y. Just now we have y. So integrate y, we get y squared divided by 2. And then we evaluate from 1 to 2. Okay. So we will get pi. Substitute 2 in. We will get 4 minus 2. And substitute 1 in, we get 2 minus half. Okay, and if we calculate here, 4 minus 2 minus 2, that means 4 minus 4, which is 0. Minus and minus will give us positive half. So we will get pi half, and this is just pi over 2 unit cube. Okay, this is equivalent. This is equivalent to pi over 2 unit cube. So that's the volume of solid that we will revolve about the y-axis. Okay, till then, let's meet again, and then we will find volume using another method, which is called cylindrical method. Okay, cylindrical shell method. Till now, meet you again. Thank you.